All right, happy Tuesday evening, 8th graders. This is your homework assignment tonight on chapter 4.1, how to graph a linear expression through making a table. So just a refresher, a linear equation is one that when you graph it, creates a straight line. So here we've got the equation y equals 2x, and we'd like to graph it. The only way we know how to do that is by finding solution points, graphing them, and then connecting those points. So here I see I have no x values. So that means I have to come up with my own. What we talked about in class are the easiest x values are -1, 0, and 1. So if I come up here to my equation and I plug in -1 for x, I find that 2 times -1 is -2. Now I have to do that all over again because this time my x is 0. So 2 times 0 is 0. And then finally I need to do it a third time. 2 times 1 is 2. Okay, you always want to make sure you guys are doing 3 points because that third point is what's going to let you know if your line is truly straight or not. So now we come over here to graph it, and I go -1, -2. Make sure your points are very small. Then we've got 0, 2, and 1, 2. Now, I don't have a ruler here, so I'm going to kind of cheat a little bit and use a straight line to connect my points. You guys are going to make sure that your line goes clear across your graph and that you put arrows on the end of your lines. Because we found over here 3 solution points, but I could have picked any number for x I want. I just chose small numbers so that my points fit on the graph. Truly, any of these points lying on my line are points that I could have plugged in for x and gotten y. Even these ones in the middle that don't lie on an intersection are still solution points. They're just fractions and decimals, so we won't deal with them a whole lot. Here's another example. So again, I don't have any x values listed here, so I'm going to come up with my own. I personally like -1, 0, and +1 because they're going to keep my numbers small so that they fit on my graph. So -4 times -1 gives me +4, -5 gives me -1. Plugging in a 0 here, I get 4 times 0 is 0, -5 gives me -5. Finally, I plug in a 1 for x, and I get -4 times 1 is -4, -5 is -9. So these 3 points are solutions to this equation. But those aren't the only 3. There are many, many more. In fact, there's an infinite number of solutions. So what we do is we graph these 3 points, and then we connect the points to make a line to show that all of those other points in between the ones we plotted are also solutions. So here are the 3 points that I found by doing math, and I'm not going to use my straight line this time, but you guys would definitely use a ruler, because look what's happening to my line. Oh my gosh, not even sure that could be considered a line. But we're going to put arrows on the ends of it. Now, any point that I created on this line would still be a solution point to this graph, in addition to the 3 that we picked. Okay, next one. Now this time I notice I have a fraction, so I'm not going to use my numbers -1, 0, and 1. I'm going to use -4, 0, and 4. And I chose 4 because that's what my denominator is. So now I come up here and I plug in -4, and I get -4 times 1/4 is -1 minus 3 is -4. Plugging in a 0, 1/4 times 0 gives me 0, minus 3 is -3. Putting in a +4, 1/4 times 4 gives me 1, minus 3 is -2. Now again, these 3 points are solutions to my equation up above. However, those are not the only 3. I could pick anything to plug in for x. Even 1, 2, and 3, which we talked about aren't smart numbers to pick because they're going to give me fractions. Those are still values I could pick for x. And you'll see that they'll still fall on my line. 1, 2, 3, 4, 1, 2, 3, 4. So there's point 1, point 2, and point 3. Again, you guys will be using a ruler for this so that you don't have the problems drawing a straight line like I do. Extend it through the graph, and then add your arrows to the end. So again, you can see here that x is 1 is still located on my graph. It's just a fraction. X is 2 is still located on my graph. It's a fraction. So this line contains all of the solution points to this graph. Now we've got this really weird equation, and I hope you guys can tell it's weird because we're missing the x. Now, what's the only thing I can plug in for y here to make this a true statement? It's 4. 4 is the only thing that can equal 4. So that means that y is always 4. Now, x isn't in the equation, so that means x is going to go wild, it's going to go crazy, it can do whatever it wants. But because I want my life to be easier, I'm going to make them small numbers that fit on my graph. So let's get a little wild and crazy and do something like 2, 4, and 6. So now I've got 2, 4, 4, 4, and 6, 4. When we connect our points, you guys see that we have a horizontal line. If you remember from class today, when we did our activity, when I asked you guys to pick points where y was always the same, you also got your horizontal line. So let's look at our equation. This says x or y equals 4. So if I come over here, my graph is crossing at y equals 4. Okay, now this is another weird one because this time we're missing our y. So again, x equals -2. So the only thing that can make this statement true is if x is -2. So x is going to be -2 every time. Now y is not up there, so y is going to go wild, it's going to go crazy, it's going to be insane. So insane that I'm going to pick 0, 1, and 2. Yep, pretty crazy. So now I've got -1, 1, -1, I'm sorry, -2, 0, -2, 1, and -2, 2. Connect my points, and this time I have a vertical line. Obviously, Ms. K is not very good at making lines when using her mouse to draw them. So, when we have an x equals with no y, our graph becomes vertical. It's still a straight line, but it's straight up and down. So let's look at our equation. I had x equals -2, and you can see here that our graph is crossing at where x is -2. Okay, last example here is a word problem. So in this situation, my y is representing dollars of renting a movie for X days. So I'm still going to make my table to solve this. But instead of using our typical x values of -1, 0, and 1, I can't use -1 because I can't have negative days. So in this situation, I'm just going to do 0, 1, and 2. So let's plug 0 up into our equation. 0 times 2 plus 4 is 4. 1 times 2 is 2 plus 4 is 6. And 2 times 2 plus 4 is 8. So let's go ahead and make sure we label our axes. So this one is going to be days, and this one is going to be dollars. So when I rented a movie for 0 days, it still costs me $4. It's like a membership fee. 1 day would cost me $6, and 2 days would cost me $8. So this time, since it's a word problem and they're going to ask me to interpret something here, I'm going to get out my line again. And I'm going to make my line as straight as possible going through my points. And then add my arrow to the end. So I've created my graph, but if I look down here at the next question, they said to use my graph to determine how much it would cost me to rent for 3 days. So 1, 2, 3 days, scroll up, puts me here, which would be $10. So let's double check in our equation. If I plugged 3 in here, I would have 2 times 3 equals 6, plus 4 does equal 10. So that does come out to be true. I don't know if you guys saw this pattern here, but each time we were counting up by 2, so the 10 also works in that way. So a couple things just to keep in mind, guys, for tomorrow. You always need to do 3 points when graphing a line just to make sure your work is accurate. Anytime you see a y equals without an x, you're going to have a horizontal line. And anytime you have an x equals without a line, you're going to have a vertical line. All right, guys, thanks for watching, and I hope you have a great night.